Hi everyone, this is Mrs. Jackson. This is Chapter 3, Section 5, Part 1. In Section 5, we're going to be looking at something called binomial expansion. That's just a fancy name for taking a sum up to some kind of power. And we've certainly already looked at the square of a sum, and I'm sure if I gave you a cube of a sum, you could sit down with some paper and go ahead and do all of your distribution and figure out what its equivalent polynomial expression is. And if you had a lot of time on your hands and a lot of paper, you can use your polynomial multiplication skills and find the expansion of higher powers, such as 7 or 9. It would take you a long time and you'd have to be pretty organized with your work, but you could find what that equivalent expression would look like. In this section, we're going to talk about something called Pascal's triangle and the binomial theorem, and learn how to actually do binomial expansion fairly quickly and efficiently using the patterns of numbers found in this really unique triangle called Pascal's triangle. Okay, so let's get started. In this section, we are talking about a young mathematician. His name was Blaise Pascal. He was French. And he spent most of his adult life in the 1600s, although he was born in the late 1500s. And he was one crafty kind of guy. He was homeschooled by his father, and he was a bit of a prodigy. He did all kinds of things in math and science, and one of the things that he did work on that was named after him is called Pascal's triangle. You may have already seen it. We could actually spend literally a month on Pascal's triangle looking at all kinds of different patterns in it, and we would still have things to talk about. It's really unique and amazing. But we're going to be using it for one particular thing here called the binomial expansion. And as I had already mentioned, binomial expansion is where we raise a sum. So let me write this down. Binomial expansion is where we raise a sum up to some kind of power or exponent, and then simplify it all out. And so, as I said, we can all do that already, knowing how to multiply polynomials together. All right, so let's take a look at this amazing triangle. It's called a triangle for obvious reasons. We've got 3 sides. Notice that the number 1 is continuous on these 2 sides here, and then the numbers in between have a pattern to it. You can pause the video if you want to see if you notice what that pattern is. Otherwise, if you just want me to tell you what's happening here, is every number here, first of all, the ones will continue. If we keep going with the pattern, we'll just keep going down here with the ones. But then these numbers here are the sum of the 2 numbers above it. So the 2 has 1 and 1, so the sum of them would give you 2, and then come down here. This 3 is a 3 because it's the sum of 1 and 2 above it. And same here. And then you step down a row, and the 4 comes here because it's the sum of 1 and 3. The 6 is the sum of 3 and 3, etc. So when we use the Pascal's triangle to help us with binomial expansion, it's important that we label each row a certain number. And you can use Pascal's triangle, as I said, for all kinds of different things, and you don't have to label the rows in a certain way for other applications, but for binomial expansion, we need to start with this very first row we're going to call row 0, not row 1, which is a little bit weird. I'm going to put this over here. I'm going to call the rows like n equals. So that's going to be n equals 0, n equals 1, n equals 2, n equals 3. And hopefully you're anticipating n is going to end up being this exponent when we raise the sum to a power. So let's try to keep the pattern going here a little bit for 4 more rows, just so you get some practice. So I'm going to go n equals 6, n equals 7, n equals 8, and n equals 9. And let's just see what's happening here. So we're going to keep that 1 going down. I didn't leave enough room for myself here, so I'm going to go smush it in a little bit. But we're going to keep this pattern going. So I'm going to go with a 1 out here. And it's not a very good 1. 5 plus 1 is 6. We're going to put 15, 20, 15, 6, and keep your 1 going. The next row, keep your 1 going. And then we have 7, 21, 35, 35, 21. Notice the symmetry. 7, and keep the 1 going. We got 1 out here. 8, 28. Let's see, 6, 56, 70, 56, 28, 8, and the 1. Finally, we got 9, 36, let's see, 14, 84, 126, another 126, 84, 36, 9, and 1. My numbers don't exactly line up that great, but you get the idea. So this is Pascal's triangle, and this simple little triangle, actually it's fairly complex, is going to help us with our binomial expansion. Thanks for listening. Hope this helps.